This week we've been talking about solving equations and we've been using manipulatives. But Tuesday in class I showed you a little bit of how to do it with numbers, and you people at home have not seen the numbers at all. So we're going to have a video on how to make that correlation between the manipulatives and the numbers. And then you're going to have a little practice maze that I'm going to show you how to do, because I have been looking at the mazes that we have done previously, and some of you really understand how to work that maze and some of you really don't, because I'm seeing a lot of you're not starting where it says to start, or you're not choosing the right path. So I want to kind of go over exactly how to do these mazes with you also. Okay, so let's start out with we'll make the model of the problem that we're going to work, and then I will show you how that translates into numbers. So let's say we have 2x plus 4 equals 8, and we want to make that with manipulatives. So we will put our variables are our x's, so we will put 2 cups, and then positive 4 would be 4 yellows, and positive 8 would be 8 yellows. Okay, so when we make models, the first thing we always do is check our model. We have 2 variables, so yes, we have 2 variables. We have positive 4, which is 4 yellows, and we have positive 8, which is 8 yellows. So the first thing we're going to do is we want to get our variables by themselves. So we need to get rid of this 4 and somehow get it to the other side. So what we're going to do is we're going to add its additive inverse. Add the opposite. So positive 4's opposite is negative 4. So I'm going to add negative 4 to this side. And if I add negative 4 to this side, I also need to add negative 4 to this side. Okay, once I do that, I see that I have 0 pairs, which are the same thing as additive inverse. A positive 1 and a negative 1 makes 0. So we're going to remove our 0 pairs. I also have 0 pairs on this side, so I'm also going to remove those. And I'm left with my variables and positive 4. So essentially this says now that we've removed this, now this says 2x equals 4. So now we need to divide these 4 into these 2 cups, and we do that one at a time. Our answer will be positive because our chips are yellow. 1, 2, 3, 4. So I don't need to know how many's in both cups. I only need to know how many's in 1 cup. So 1 cup leaves us with positive 2. So positive 2, x equals positive 2. So we've seen the cups, and I want you to be thinking about those cups as we do this same problem, but this time we're going to do it with numbers. So our original problem was 2x plus 4 equals 8. And if we're going to do that, we need to be able to visualize that model. What would we have done first? We would have wanted to isolate our variable, which is this 2x. So we would do the additive inverse of 4. So this is positive 4, so if we add the opposite, we would do negative 4. And if we did negative 4 to this side, we would also do negative 4 to this side. So this one equals 0 because positive 4 minus 4 equals 0. So we would bring our 2x down, and it equals 8 minus 4 is 4. So now, if we were still doing our model, we would still have 2 cups and we would have 4 yellows. So now we would need to divide these 4 yellows into these 2 cups. So we're dividing the 4 by 2, but we have to do both sides. So we would do 2 divided by 2, and also this side, 4 divided by 2. So this really says 2x divided by 2, and I know that 2 divided by 2 is 1. So we're only left with x, 1x, but we don't write 1x. We just write x. X is equal to 4 divided by 2, which is 2. So we got the same answer. X is equal to 2. Okay, let's try another one. This time I'm going to split my board in half so I can write the variable on both sides, and so I can model it with cups and chips on one side and then do it with numbers on the other side. So this time we're going to do 2a minus 6 equals 2. And I'm going to write the same problem on this side. 2a minus 6 equals 2. Okay, so on this side I'm going to do it with cups. So I would have 2a. And I would have negative 6. And it's equal to positive 2. Okay, so this is what that model would look like. I have 2a, 2, 4, 6, so that's negative 6, and I have positive 2 equals positive 2. This is the same thing as this. 2a minus 6 equals 2. So the first thing I would do is add my additive inverse. So the additive inverse of negative 6 is positive 6. So I would put my positive 6 here. Let me turn this one over. And if I add positive 6 to this side, I also have to add positive 6 here. So if I were doing with this with numbers, I would have done this. I had negative 6, I added positive 6. So I would have done plus 6. And when I did plus 6 here, I also had to do plus 6 on the other side of the equal sign. So I would do plus 6 here. So this is what I have just modeled. Now, these would equal 0 because they are 0 pairs. So this one equals 0, so it'll go away. And then 2 plus positive 6 is positive 8, which is what I have here. And then I'm going to bring down my 2a equals 8. So now I'm left with 2a equals 8 over here. And I would divide my positive 8 into these 2 cups. So I'm dividing positive 8 by 2. So I would divide this side by 2 and divide this side by 2. So I would divide. Remember, your answer is positive because your counters are yellow. And you are left with positive 4. Uh-oh, I put one too many in one of the cups. I would be left with positive 4. So let's go back to our number side. We're going to divide both sides by 2 because we had 2 cups and we need to divide the 8 into the 2 cups. So 2a divided by 2 is equal to 1a, which is what we were left with. 1 cup, which is 1a. And 8 divided by 2 is positive 4, which is what we got. Okay, so That was the whole point of us working with manipulatives. So let's get rid of our manipulatives, and let's try to solve some problems with just the numbers. Let me erase my board. Let's say we have x plus 7 equals 15. Now we know when there's no variable when there's just a variable that means it's actually 1. So 1x. So if we were doing the cups, we would only have one cup here. We would have one cup, we would have positive 7 and equals positive 15. So the first thing we would do would be to get rid of our 7 by doing the additive inverse, which would be negative 7. So we would have put 7 reds. Now, when you put 7 reds here, you would also have to do 7 reds here. So this one goes away. I'm just going to X it off instead of writing a 0 this time. So I would bring my X down, and then 15 minus 7 is equal to 8. So here I am left with 1x is equal to 8. So I would have 1 cup and 8 counters, and then I would put all 8 counters into that 1 cup. So x is equal to 8. Let's try it another way also, because you will see it different ways. You may see it as 8 plus 2x equals 4. Now this is different because my variable is in a different place, but I would do the same thing. I would put cups for my variables, I would put positive 8 here, and I would put positive 4 here. So the first thing I would do is my variable still wants to be by itself, so I would get rid of anything that wasn't the variable. So this was positive 8, so I would put negative 8. And if I do negative 8 here, I would also do negative 8 on the other side of the equal sign. This one goes away because it's equal to 0. Then I would bring my 2x down, and 2x is equal to 4 plus negative 8. So my signs would be the same, so I would subtract and I would get 4. And my answer would be negative 4 because the largest absolute value is 8. Now I'm going to divide both sides by 2, and I would get x is equal to negative 4 divided by 2 is negative 2. So x equals negative 2. Now, I could go back up here and put it back into my original problem. If I know that x is equal to negative 2, let's see if that works. Here's my original problem. So I would say, let me get rid of this too, because that's not part of the original problem. I could say 8 plus 2 times negative 2 is equal to 4. Let's see if that works. 2 times negative 2 is negative 4, and then 8 minus 4 is equal to 4, so our answer is correct. So it doesn't matter where that variable is. If you can solve for it, you can stick it in that equation and see if it works, and that'll tell you if your answer is correct. What if you have negative 4x plus 8 is equal to 36? What do you think you would do there? We haven't done any with a negative variable. So let me show you. You would have 4 variables, 4 cups, And you would know, except your cups would be upside down because it's negative. Okay? So you would have 8 yellows and 36 yellows. So we're going to get rid of that positive 8 just like we always did. So we would do negative 8. We would do the inverse operation, and we would also do negative 8 over here. This one would go away. We would bring down our negative 4x. And 36 minus, excuse me, that went down the wrong way. 36 minus 8 is positive 28. So now we would need to divide by negative 4. Don't leave off that negative sign. So we would divide both sides by negative 4. Negative 4 divided by negative 4 is 1. So it would just be x. 1x is equal to 28 divided by negative 4 would be negative 7. So x is equal to negative 7. Don't forget those rules. They're going to come in handy. What if you had 5 plus 5x is equal to 120? It doesn't matter where the variable is, it still wants to be by itself. So you would get rid of anything else. So this is a positive 5, so I would do negative 5. And I would also do negative 5 on this side. This one goes away because positive 5 and negative 5 equals 0, so it just goes away. We bring down our 5x. And 120 minus 5 is 115. So now we would have 5x is equal to 115. And I want you to think about this. We're really doing the inverse operation because right now we want to get x by itself, but it's still attached to this 5. And we know that when it's attached to a number or its coefficient, that means we're going to multiply these two. So to do the inverse, we did the inverse here to get negative 5 on both sides. So now we're going to do the inverse here, which is it's being multiplied. So now we're going to do the inverse, which would be to divide by 5. And I'm going to divide both sides by 5. Now I'm left with x, and 115 divided by 5 is 23. So x is equal to 23. I just wanted you to see that correlation between we're doing the inverse operation to get that x by itself. Sometimes you will see problems. Let me turn my volume off of my phone real quick because I must be in a group text. Okay. All right. Sometimes you may see it like this. 7x is equal to negative 21. On this one, we still need to get x by itself. We're already, if we were doing cups and chips, we would already be down to the 7 cups and 21 red chips. So all we would need to do is divide that 21 into the 7 cups. So if we think about it backwards, we see that this 7 is being multiplied by the x. So to get the 7 on the other side, we would need to do the opposite of multiplication, which is divide both sides by 7. So 7 divided by 7 is 1x. So we're left with just an x is equal to negative 21 divided by 7 is negative 3. So those are already kind of done for you. All you need to do is divide to get that x by itself. So x is equal to negative 3. You don't always have to have the variable on this side. It can also be on this side. So you could have 10 is equal to 5x plus 5. So if it was written like this, all you would need to do is the same thing. You're just going to the other side with it. So we still want to get our x by itself. So we're going to subtract 5. And we will subtract 5 from both sides. We're doing the inverse operation. Positive 5 and negative 5. That's inverse operation. So 10 minus 5 is 5. And that is equal to 5x. But I am not finished because I don't need to know how many are in 5 cups. I need to know how many are in 1 cup. So again, I'm going to do the inverse operation here. So I'm going to divide by 5 because the inverse operation of multiplication is division. And if I divide one side by 5, I have to divide the other side by 5. That leaves me with x is equal to 5 divided by 5 is 1. Okay. All right, I'm going to give you one. I want you to pause this video and I want you to try on your own to see if you can do it with numbers. So let's do 9x plus 18 is equal to, let's see, what could it be equal to? 36. Okay, so pause the video and see if you can do it yourself with without your manipulatives, only with numbers. Okay, I hope you paused the video and worked the problem. So the first thing I would do would be to get rid of anything but the variable. So I would do the opposite, which would be negative 18. And if I do it to this side, I also do it to this side. This one equals 0, so I'm just going to exit off and I'm going to bring my 9x down. And 36 minus 18 is 18. Now I still need to get my variable by itself, so I'm going to do the opposite. It's being multiplied, so I'm going to do the opposite, which is to divide by 9, and I have to do both sides. So 9x divided by 9 is equal to 1x, and 18 divided by 9 is 2. And that is my answer. Okay, let's take it a step further. What if there's fractions involved? What if you have 1/3 x is equal to negative 6? Well, we wouldn't have a whole cup here, would we? We would have 1/3 of a cup. So that's why we move on to numbers. This would be 1/3 of a cup to represent our x, and on the other side would be negative 6. Now, right now, this says 1x divided by 3. So to do the opposite of that, we would need to multiply both sides by 3. So times 3 times 3. So now these two cancel out. We're left with 1x, and we just write it as just an x. And negative 6 times 3 is negative 18. So x is equal to negative 18. Okay, what if we have 1/2 plus x equals 3/4? This is where those rules come back in. So again, I need to get rid of the positive x. Back up. I need to get rid of everything but x is what I meant to say. So right now I have 1/2 plus x equals 3/4. So in order to get x by itself, I need to subtract 1/2 from this side. And if I subtract 1/2 from this side, I also need to subtract 1/2 from this side. This one goes away, and I'm left with x. Now, there was one thing about adding fractions that we can't forget, and that's that we need a common denominator. So in order to get a common denominator, we would do 2 times 2, because we could use 4 as our common denominator. Whatever you do to the bottom, you have to do the top. So this would become negative 2/4, and we just bring the 3/4 over. So this one changed to negative 2/4. So now this says 3/4 minus 2/4, which would give us 1/4. So x is equal to 1/4. What if we had 2/3 x is equal to 12? Okay, so technically this says 2/3 x. We're multiplying 2/3 times x. So we need to divide. Well, what do you do when you divide? You flip the second one and multiply. So we need to multiply this times 3/2. And if we do that on this side, we also need to do that on this side. So these cancel out and equal x. They just equal 1x because it would be 6/6x. And 12 times 3 is 36/2. We can simplify that a bit further because 36 divided by 2 is 13. So x is equal to 13. Okay, let's go over this maze before I let you get started on your practice for today. This is not the same maze that you have. It looks like the maze you have, but it's a different one. So I wanted to just point out, and of course you'll be doing it through Cami, so you'll be drawing on it through Cami, but I printed this one off so I could show you how it works. So first thing I'm going to do is I'm going to look for the begin. By the way, yours is not in the same place as mine. You need to look for where it says begin on your maze. Let me see if I can get this a little bit more in focus. Okay, so when I begin, I'm going to this square. It says 2x equals 8. So I would use my marker or my scratch paper to work 2x equals 8. So I see that I'm already to the part where I need to divide. So I'm going to divide both sides by 2, and that's going to leave me with x equals 4. So I'm going to look for that answer. I see I have x equals 1/4 here. That's not my answer. I do see that I have x equals 4 here. So I'm going to draw an arrow to the next box. So this is the one I'm doing now. So this would be x plus 3 equals 8. I'm going to move this over so I can write over here. X plus 3 equals 8. So the first thing I need to do is get rid of the 3. That leaves me with x is equal to positive 5. So I am going to look for the answer. I see that this says x equals negative 5. That's not my answer. My answer was positive 5. So this one says x equals 5, so that's where my arrow will go. It will go to the next box. Okay, the next box says negative 3 plus x equals 7. Negative 3 plus x equals 7. So I know I need to get rid of the 3. So I'm going to do the opposite, which is positive 3. And if I do it to this side, I have to do it to this side. This one goes away. X is equal to 10. And it's positive 10. So I'm going to look for x equals positive 10. And I see that is right here. So I would draw my arrow to this box. The next one says 15 equals 5x. Again, I need to get my variable by itself. So it's being multiplied, so I'm going to do the opposite, which is to divide both sides by 5. X is equal to positive 3. So I will look for the one that equals positive 3. This one says negative 3. That's not my answer. This one says positive 3, so I'm going there. This one says negative 4 plus x equals negative 11. Negative 4 plus x equals negative 11. So I need to get my x by itself, so I'm going to get rid of this negative 4 by adding 4 to both sides. This one goes away. I'm left with x is equal to negative 11 plus 4 is negative 7. So I'm going to look for negative 7. Here it is, so that tells me I need to go up to this box. I have 2/3 x is equal to 12. 2/3 x equals 12. So I need to get rid of this 2/3 x, so I'm going to flip it and multiply. And I'm going to do the same thing to this side. 3 times 2 is 6. 2 times 3 is 6. We know that equals 1, and we're just going to leave it as x. 12 times 3 is 36 over 2. And we know that 36 divided by 2 is 18. So I'm going to look for positive 18, which is right here. I'm going to draw my arrow here. I hope I didn't say 13 while ago. I think I may have done that while ago and said 13. I'm in 18. X plus 8 equals 2. I have a positive 8, so I'm going to subtract 8 from both sides. This one goes away. I'm left with x is equal to negative 6. So I'm going to look for the answer, negative 6. Here it is. So I'm going to draw my arrow to the next box. (27) equals 9x. I need to get the x by itself, so I'm going to divide both sides by 9. X is equal to 3. And it's positive 3, so I'm going to go up to here. Now I have x plus 6 equals negative 15. I need to subtract the 6 from both sides, which will give me negative 21. X equals negative 21. So you can see I have finished my maze because now I have ended up at the end. I want you to notice, I had some people turn in mazes last time and you had just like done 3 across. You had drawn your arrows straight across. That's not how this works. You find the answer and then you draw the arrow across your answer. Good luck with this. I hope you do well with this. We'll work on this some more tomorrow. And then, of course, next week is our Thanksgiving break. So we'll have a week off, and then we'll come back and we'll start doing multi-step equations, which is more than two-step equations. So good luck with this, and I will see you